Good morning, dear students. How are you today? I hope you're fine. Today we're going to talk about data management. How to manage the data comes to you and organize them in a table or a graph. Let's see. Remember that the data is just recorded information. So data means what? It's just what? Recorded information. You have information and then record them as data. So I have here for an example Amy, Bill, Cam, Ifra and Farah. They got scores in the exam. So Amy scored 90%, Bill 95%, Cam 100%, Ifra 100% and Farah 80%. If we here just make a table for and write here the name and score, this table is doing what? Is clearly looks like the table. So if we complete this table to be like that, so it's a table for recording data. So I know from this table that Amy scored 90%, and if I ask you what is the score of Cam, I search for Cam and find that Cam got 100%. And if I ask you here in this table what's the score of Farah, so I will know that she scored 80%. But you could also do it in other ways. You can here do it by another ways. So I can do what here? A graph. This is called histogram graph or bar graph. So I have here a horizontal line and a vertical line. So the vertical line shows me the score up to 100 and the names of my students. So I write here the names from the beginning in this order: Amy, Bill, Cam, Ifra, then Farah. Then I see here Amy got 90%. So I'll go up until I get to 90 and draw this bar, the yellow bar. Okay. And here moving to Bill. Bill here scored how many? 95. So I'll go up until 95, between 90 and 195, and then came 100. Yeah, he got 100 score. So go up until I get to 100. Then for Ifra also 100 from your table. Yeah. And then Farah, she got 80. So go up until I reach 80 here in the score 100. This is the y-axis and this is the x-axis. So I can use this graph, the bar graph, or it's called also the histograph, to represent my data. Amy here scored a 90. When I ask here you to look at the bar graph and we will ask you what's the score of Farah, I search here, I go up until I get to this point and go here like the dotted here, it will be here 80%. And if I ask you here what are the most records for the students here, I will say that Cam and Ifra scored the most records, or scored the most number, that is the most percent, I mean, that is 100%. We have got Cam and Ifra here. We can also represent data by the dot plot graph. This dot plot graph we represent here, or we write here instead of people their scores. We just write their scores instead of people. Yeah, here I have to write the scores: 90, 95, 100, 100 and 80. So I write here from the least 80, 85, 90, 95 and 100. So I have here to list the, I will write, and I will represent, it will be represented here what, not the students, the scores of the students. So if I look here, I have the 80 here. How many students got 80? Just Farah, so I will put here just one. Here I have how many got 85. No one got 85. How many got 90? Just Amy, one student. The score of one student here will be 1. And then how many students got 95? Just 1. And 400 I have 2. Right. So this is my dot plot graph. And if I want to know the range here in this is what is the difference between the least and the greatest value. If I look here to this slide, the range is the number between the lowest point and the highest point. Here I have 80 and here I have 100. So 100 minus 80 will give me 20. So the range here is the maximum minus the minimum, which are 100 here in the dot plot graph, minus what? Minus the 80 will give you 20. And here if you look to the histogram or the bar graph, what's this? The highest one is 100. As I see, I have 200s. I know the highest one is 100 and the least here is 80. So 100 minus 80 will gives you the same 20. And if you look at the table here, yeah, the table that shows us the data, okay, yeah, so horizontally. So I have here the highest level or the highest score is 100 and the lowest score is 80. So the range here will be 100 minus 80, which is 20, the same. Yeah, it makes sense now that all the graphs that I have gives me the same range, because graphs are just interpreting or explaining data you have got. And can I ask you a question? How many people scored below 100? If you look here to this table, how many students or people scored below than 100? I have here Kaim and Ifra, yeah, got 100 scores. So below 100, how many? Let's count. Amy, Bell and Farah. There are 3 students. And in the bar graph, it should give me the same answer. So below 100, below, this is the two of them, the 2 students here, 100. Below them, I have Amy, Bell and Farah. And here in the dot plot graph, how many students got less than 100? I have here Amy and Amy. The scores of these are the scores of Amy, and the 100 here I have Kaim and Ifra, the scores of Kaim and Ifra. And below 100 here, the 3 dots here for, yeah, Amy, Bell and Kaim. Amy, Bell and, excuse me, Farah. Amy, Bell and Farah. So the three here graphs gives me, and the 2 graphs and the table gives me what? Gives me the same answers for the question. You would have gotten 3. You would have gotten here 3 in 3 of them, in the 3 of them. And if I ask you a question about what is the most frequent here record or scores, I can see in the table gives me that they are 2 times I have got here 100 scores. 2 times I have got 100. So Kaim and Ifra, both of them got 100. So 100 here is repeated 2 times. But here 90 just 1 time. 95 just 1 time, 80 just 1 time. So the most frequent here will be, yeah, 100 score. And here in the bar graph or the histograph, I have here this just repeated 1 time, this length of the bar, and this just 1 time, and this 1 time. But I have here the 100 score, it appeared 2 times. Okay, so the most here is 100. And here it's very obvious or clear here, just 1 time, 1 time, 1 time, and here 2 times. By that, I know that the data here is what? It's the recorded information that you collect by yourself or you collect from a library. So now we are going to have the difference between them. Okay, moving to this slide, I want you to know that here I have an example for collecting data. Maya wanted to find out the favorite singer of her classmate. She conducted a survey by herself. She asked this question: who is your favorite singer? Brian Adams. Got how many here? This is, do you remember, this is called what? Yeah, this is called tally chart. I have here how many? 5. 1, 2, 3, 4, and this cross one is 5. So this is 5. Susan got Susan. Okay, this is a singer. I have here 5 also. Celine Dion got 5 and 2, 7. And then Sam Roberts got 3, and Shania Twain got 2, and the other singers got, here I have 10 and 1, 11. So Maya recorded the result in a tally chart, as I told you. So Maya concluded that Celine Dion was the most popular singer of those named. Celine Dion, she got Celine Dion how many here? 7. However, if all the votes in the other category were for the same person, that the person would be the most popular. Since Maya collected the data herself, this is important, I want you to know that they are called primary data. Primary data that I collect myself. Data that are found from the library or using the internet are called secondary data. They are called here sec data. Moving to this point, also it's important that a survey is conducted and data are collected in a fair way. Sometimes the way of a question is asked or written might persuade a person to answer in a certain way. This type of question is biased. A survey question must be unbiased. That is, the question must not lead a person toward a particular answer. How come? Let's do an example to understand what we are saying. How is each survey question biased? Rewrite the question so it's unbiased. Many students are bored at the end of August. Okay, focus here. Many students are bored at the end of August. Should the school year be longer? What do you think? This is a biased what question? The question include a statement. Why? About, this is the answer, about how some students feel. This may encourage people to answer by yes. Yeah? So the unbiased survey question must be like that. The school year is 10 months long. Should it be longer? This is an unbiased question. So you can say yes or no without any pressure of me of telling you something like an example. Do you think Mary is a good girl? She's doing a lot of things wrong. So I'm pressuring you that to say that to say she is wrong, right? So here, can you see this? Okay, now moving to another question. Okay, I have here B. Some people are sick after visiting patients in a hospital. Do you think patients in a hospital should have visitors? Of course, this is a biased question. Why? Because I tell you now, some people get sick after visiting these patients. So as if I'm telling you don't go to visit patients. Okay, so the answer is, the question includes a statement that may encourage people to say no, to answer by no. An unbiased survey question is, should patients in a hospital have visitors? This is the unbiased question, would be like this. Okay, by now we have got what we have learned now how to interpret data by using bar graph, histograph, this is the same, or dot plot, or a table. And we have also learned that we have something called primary data and secondary data, primary data that you collect by yourself, okay, or secondary data that you collect by a library or internet or something like this. And I've got also the biased question and the unbiased questions. Okay, moving to another point. Okay, moving to another slide. Okay, here I have data can be organized in a tally chart or frequency table. A frequency table is what is a tally chart, as we know the tally chart. Yeah, with what? With an extra column here. So I have here what this is called frequency table. A tally chart plus what? Plus extra column here. So it's called now frequency table. So if I have here for the blue, the birds here, the tally, the frequency for the blue jay, I have here how many? Yes, 5, right, 5. And cardinal for sparrow, yes, 15 here, 15 plus 2, 17. And here for the robin, I have 10 plus 1, 11. And here for the check, I can't see well, check D, yeah, 5 and 2, 7. So I write here the frequency. So it's called what here? Frequency table. Frequency table. Okay, now it's easy to do what? I want to convert this to pictograph. Pictograph. Let's see what we are going to do. The pictograph. Construct a bar graph. Now here he asked me to do what? To construct a bar graph of Andrew's data. The same data here for the frequency table and for the pictograph. He asked me to do what? To do a bar graph. Okay, compare the graph and tally chart. How are they alike? Let's do it now. Construct a bar graph. Below left, one square represents 2 birds. Just one square represents 2 birds. Let's do it now. The longest bar here, after we draw the bar graphs here for the blue jay, I remember they were, yeah, here, yeah, they were 5. So at 5, then 4. The blue were 5, and then the cardinal 4. So here I draw for the blue, yes, 5. Yes, 5 between 4 and 6. I have here 5. Then the cardinal, I said 4. And here the sparrow goes up. Yes, 17 here. Yes, 17. Then 11. Then 7. Then 11 for the robin. And for the check D, 7. So after doing so, I here compare the what? The tallies. The tallies here. What's the tally? The tally here, these lines together is called the tally. The tally chart I have here, when I compare, it's the same. So what did you recognize? That all the charts I have done now gives me the same data, the same information. Okay, so the graphs here helps me in math to interpret the data, to represent the data and understand what's happening with these data. Okay, so I have here the longest, okay, the longest bar on the bar graph represents the same bird as the longest row of the tally chart, here for the sparrow, and here for the also the sparrow. And if you go up in the pictograph, we'll see that we have the sparrow, the longest one. So when you rotate the tally column, turn counterclockwise over the right, its shape matches of the graph bar about left. Okay, moving to the other slide. Talking about the line graph, work with the partner. Here I have, it's for school now, we're not in school, so working alone. Okay, Mads, who measured the mass of her pet Junia, a pig. This is okay, every 5 months until it was 25 months old. The data here are shown at the left. Here I have the data, the information. One person draws a bar graph. The other person draws a line graph. So, during which period did the Guinea pig gain the most mass? It was a pig, okay? So, not a rat here or not a mouse here, so it's pig. So, what happened to the mass of Guinea pig after 15 months? After 15 months, does this make sense? Predict the mass of Guinea pig at 30 months. What should we do now? I have this pig. It's not pig. This is not pig. Okay, a pig. It was a pet for Madhu. So he grows his pet 5 months. The first month when he measured its weight, it was 200, and here in 10 months 350, and in 15 months 480, in 20 510, in 25 it was 520. So here when he says that during which period did the Guinea pig gain the most mass, here the most mass, which period here, at what? At 25 months. Okay, at 15 months, what happened to the mass of Guinea pig after 15 months? Yeah, it became 480. Moving to this, a line graph displays data that change over time. A line graph displays data. Yeah, here I want you to focus on this. The line graph, we use it mainly when we want to display data that change over time. The line graph on page 189 shows how the, okay, we're going to page 189, and I will show it to you. From 2 to 13 years, each line segment goes up to the right. Okay, I will show you now. Page 189 here, yes. So here what it's called, here I have the, okay, I will show you now in page 100, in the other page. Okay, this represent what? Again, to focus, I have a line graph. The line graph most used to display data that changes over time. As in this example, I have a girl and I measured her length through the years she lived, and she's still alive, thank God. So here, can you see this? Yeah, this is the graph here. It's a line graph. Why? Because it represents here the different lengths for hair. Okay, here in 2 years, yes, in 2 years she has got 80 centimeter, and then, okay, I will show you 80 centimeter, and for 3 years she got, yeah, here she got, in 2 years she got 80, and then in 3 years she got, yeah, 90, and then in 4 she got 100 centimeter, then in 5 she got 100, I suppose, and 10, and in 8 she got 123 or 122. It's not here, it's not written here the small numbers. So, and it remains the same in age of, of 16, 17 and 18. We can use the line graph to find values between data points. At 11 and a half years, Lee was about 148 centimeter tall. Here in age of 11 and a half, she got 148. So I need to know now that the line graph represents the data over time. It's most used to represent data over time. In this example here, the graph goes up to the right. Here shows me the Canada's population. Okay, this means the number of people in Canada over years. Here, over years, as I told you, I want to display data over time. So I mainly use what? I mainly use the line graph to show the growth, the upgrowth here of the population in Canada. Okay. Okay, I want you to focus with me. I want you to experience this technology using spreadsheets to record and graph data. So what should we do now? Okay, sheets software such as AppleWorks can be used to record then graph data. This table shows the favorite sports of grade 7 students in Mona's school. Okay, to graph the data using AppleWorks, follow these steps. Open AppleWorks, choose a spreadsheet, AppleWorks in the computer. So choose a spreadsheet, enter the data into rows and columns like this. Okay, to create a bar graph, highlight the data, I will enlarge this for you. It's kind of internet work. To create a bar graph on the internet using the computers, highlight the data, include the column heads, but do not include the table title. Don't include the table title here. Click the graph icon. So on the toolbar, a chart options dialog box appears. Choose bar, then click OK as shown below to the left. Here, then here, what should be done, I will tell you now. Okay, the next step, in the title box, type favorite sport. In the title box, type favorite sport as shown below left. Then to insert labels, click the axis tape, select x-axis, type sport, select y-axis, type number of students as shown below right, then click OK. Your graph should look like this one. If you want to do this by yourself, try it by yourself, it's very interesting. Okay, to create a circle graph, and now I'm going to tell you what's a circle graph. Use the data on page 193 as I showed you now. Highlight the data as shown below left. Do not include the column, heads, to, or title. Okay, then here, click the graph icon on the toolbar. A chart option dialog box appears here. Choose the pie and then click OK as shown bottom right. The circle graph shows a legend at the right. The legend shows what sport each sector represents. Okay, this is to create also a line graph. I will leave this in the video if you want to try. So you can use this to make your charts on the computer, okay, using that technology, not just by yourself by drawing. You can use that technology too. So moving to, I want to show you the last thing in the whole week. To this week I'll show you now the circle graph. Okay, moving to the pie chart. You can use pie chart to display data showing how an amount is divided or shared. Okay, so the angles at the center of a circle adds up to 360 degrees. When you draw a pie chart, you must make sure that you label each sector and draw the angles accurately with a protractor, using your protractor. To draw pie chart, you must have the angles. To draw this pie chart in the shape of circle, you have to or must to have angles. Add all amounts together, divide 360 by the sum of the amounts, multiply each amount by the quotient. This is the steps. Then draw by protractor in the pie chart the sectors and label it. We are going to find out what are the steps step by step now. To find the amount equals angle over 360 time total amount as given. Okay, to complete the table use the scissors. So let's see. We have here in this one yeah, this is clear, more clear. Example, sector graphs, pie graphs. At a busy toy shop, this is example, at a busy toy shop, 900 widgets were sold during a sale. The sector graph shows the breakup of the colors of widgets that were sold. Here, if he gives me this one and asks me some questions, so what fraction of widgets sold were red? Red, I have here red. Yes, it's 80 degree. So 80 degree divided the total here I have of any circle, 360 degrees. So I here make what? Simplify. What does it mean simplify? Simplify means divided. 80 here and 360, the 0 goes with 0, then 8 with here divided 10 and divided 10 of course, then 8 and 36, 8 divided 4 and 36 divided 2 divided 4 will give me 2/9 as after simplifying. After this, how many blue widgets? It's very easy, I know. How many blue widgets were sold? I want to look for the blue. Yes, in this one I want you to focus with me. I have the quarter. Can you see this circle? This circle, the perpendicular here area, the perpendicular measure, the perpendicular measure is 90 degree. Then do you know that half of the circle will be the whole circle 360? So half of the circle 180. So quarter of the circle will be 90 degree. So I here said what he needs me to know the blue. So quarter times 900, that will give me 225. Okay, from where I got 900, this, don't forget this one, 900 widgets. Okay, moving to another point. Okay, moving to the other point. How many red widgets were sold? I have here the red 80 degree. 80 degree, I want to know the fraction. So 80 degree over what? Yes, over 360, the total. Do you remember what we have taken for the probability? Yeah, the probability. So here I have 80 over 360, yeah, times what? Times the 900. So after simplifying, I showed you here the simplification. After simplifying 80 and 36, so 2 over 9, we got 2 over 9 times 900, so it will give me at last 200. So what percentage of the widgets were sold green? I have here the same steps here, 72, because here 72 over 360, then simplify, then multiply by here 100, so it gives me 20%. Okay, here miss, okay, I can hear someone asking now, why miss I write here 100 not 900? Because here he asks me for how many widgets, and here he asks me for what? Yes guys, percentage. So percentage I multiply by 100, don't forget. Okay, by now we have covered what? We have covered the how to represent data and the importance of representing data, the data management, and the line graph and the pictograph and the bar graph, and also the pie graph. I will send for you worksheets covering all of this, and I need you to kindly study well from this presentation and from the PowerPoint presentation and from the worksheets, and do your homework daily and resend your homework on Google Classroom, so I know that you understand what have been taken. Thank you, my dear students, for listening. See you inshallah. Mrs. Dina.